Alright guys, we're here to talk about the periodic table and just get you a little introduction into how this works. So this is the periodic table I have saved in my desktop, and I like it a lot because it's got it's very colorful and very pretty. It's got all the groups in their own little colors. It shows the atomic number up here, the number of protons up here. It shows the molar masses, or the atomic masses on the bottom. It even has a symbol and the actual names, which is nice. And it, even in the top right corner of each one, it shows its most common charge or its most common oxidation state, which is very helpful. Some of them have a few, but some of them only have one or two. So it's really nice when you start looking at reactivities and how their electrons work, but we'll do more on that later. So you want to keep a periodic table, print one out, download an app on your phone. I don't really care, but you will need a periodic table on each of your tests. So this is all free information. It's not a secret. Make sure you have a periodic table available to you. So this is the one the IB students get on their exams, and it's the same kind of one. I just kind of copied their slide and put it into yours, but here's your, just to show you that the periodic table has 7 rows in it, right here, and it has 18 columns, okay? So these columns are called groups. As they go up and down, those are groups, and the periods are left and right. Now, you can see here that there's 18 of them. Now, you can say group 18 over here, or group 13, 14, 15, 16, 17, 18, but we also can number them a different way. So group 1 is over on the left. Group 1 and 2 are still the same. But we will sometimes skip the transition metals, sometimes, and we'll call this group 3. Okay? So if I say group 3, that's probably what I mean. I'm probably not talking about this group, I'm probably talking about this group. And so group 4, 5, 6, 7, and 8. That's because there's usually, for your class, there's a maximum of 8 valence electrons. You've probably heard of valence electrons before. That's what that's dealing with, okay? So you've probably heard of that before. You're probably more used to the red numbers than you are with the black numbers. And we'll just roll with that. I'll explain more about this as it becomes more pertinent later. So you may already know about the alkali metals. That's the group 1. So if you hear me say alkali metals, that's what I'm talking about. Now the group 2 is called the alkaline earth metals. These guys in the middle are called the transition elements. And now these guys at the bottom are called the inner transition metals, or the rare earth metals. Alright? This group over here, this group 17, this next to the last group, is called the halogens. So if you hear me say halogens, that's what I'm talking about. And these are the noble gases over on the end. Just this little wonky group right here is called the representative elements. That's not a very common term, and that's not a tested thing, but it's kind of cool if you ever hear me say that. Those are mostly things that covalently bond. Just an FYI. Now, you can separate periodic tables into other ways too. So if you look on the left, the metals like to live on the left side of the periodic table, with the exception of one guy. That's hydrogen. Hydrogen is that one exception. And then the nonmetals lived on the right side. Okay? So metals on the left, nonmetals on the right. The thing that separates them is the staircase. Right? The yellow staircase. You will see a yellow staircase in my room, but you can also draw a staircase on your periodic table if you have a printout. Highly recommend doing that, because not every periodic table you print out on the internet will show that staircase. So anything that touches the staircase is called a metalloid. Alright? So if the fun thing to do is to print out a blank one and just color it yourself. And so anything that touches the staircase is a metalloid, with the exception of aluminum. All right, aluminum is a metal. You should be able to remember that. We're all familiar with aluminum cans, and we are familiar that those are metals. So that should be an easy thing to remember. Aluminum is a metal. I've had students ask me about why does the staircase keep going. Well, astatine is not well studied, and these here are just not well studied either. So we're not entirely sure. We're kind of guessing upon their properties. So those aren't really covered in this class. We'll just move on. Now there's another way to sort the periodic table is by their electron structure, which looks like this, but we'll just move on. And move on here. There's another example. And here's another example of the periodic table. And then here's a really cool example you might actually see. Instead of having those bottom two rows, it's actually inserted them where they're supposed to go. Alright, that's actually what they really should look like. But we'll just move on. We'll come back to how this all structure stuff is supposed to look later. So I told you about the metals, nonmetals, and metalloids. Well, let's talk about the properties. You need to know that. So it's in your notes. There's a section in your notes for this. Properties of metals, they are lustrous, which means that they're shiny. They are malleable, which means you can pound them into sheets, with a hammer. They are ductile, which means they can be drawn into wires. They are good conductors. So they're very good conductors of electricity and heat. For the most part, that's because they have free moving electrons. That's what's going on here. And they are typically solids at room temperature, except for mercury. Mercury is a metal and it is a liquid at room temperature. But the rest of them are all solids. Now, the nonmetals are non-lustrous. So they're not shiny. They're usually kind of dull. Think about carbon. Carbon's a nonmetal, and you can tell what coal looks like. It's not very shiny. It has poor conductors of heat and electricity, and they are either brittle solids, they are liquids, or they are gases. So they're kind of a grab bag right here. Mostly gases. A lot of gases. Those noble gases. Bromine is a liquid at room temperature. But carbon is a solid, phosphorus is a solid. So it just kind of depends. Now, metalloids have properties of both metals and nonmetals, okay? And now the particular thing you need to remember about these is that they are semiconductors. So like silicon. One real reason why silicon is in so many electronics is because it's a semiconductor. It doesn't burn out and conduct a ton of heat, so you can change the conductivity of it. Which is pretty awesome, great property of it. So take a look at your periodic table. Is magnesium a metal, nonmetal, or metalloid? That's correct. It is a metal. And what about sulfur? I can hear you yelling at the screen. It's a nonmetal. And then arsenic, that's a metalloid, okay, because that one's touching the staircase. And that's actually it, all right? So just know those properties of metals and be familiar with where the periodic table is and where to find it. Know your metals, know the nonmetals, and know the metalloids. All right, have a great day.